Yeah, can you just make sure that the audio quality is fine? Okay, so hello everyone. Welcome to this session of Going Serverless with Node.js. I'm Shivam Mehta, core committee member of CodeChef-VIT, and I'll be taking this session. What I'm aiming through this session is to get you guys a glimpse of what serverless architecture looks like. I will start off with what exactly serverless means and why are huge enterprises shifting towards serverless architecture. Then we'll be creating a simple CRUD applications continuing our previous series that we had. In the last series, we made a book CRUD application that was built on GraphQL. So make sure you check that out also. And today we are going to make the same application, same book CRUD application using the AWS Lambda. We'll be using DynamoDB for our database. So yes, a lot of cool things planned out, and I'll try to keep things interesting. If you have any doubts throughout the session, you can type it on the comment section. I will try to answer them. So yeah, let's wait for like few seconds and we'll start the session. All right, so serverless framework. Now let's get this thing clear straight away. Is serverless truly serverless? So the sad reality is it's not truly serverless. Shocking, right? Well, of course, servers do exist, and basically we are using the cloud providers' servers to manage our applications. Now, the main aim of the serverless technology is that we are throwing our management and our resources to the cloud provider. So we are not taking any headaches of maintaining the server. We are just using the functionality. So once that we have known that the serverless is not actually serverless, let's define what serverless is. This is what Wikipedia defines the serverless computing as. It's a cloud computing execution model in which the cloud provider runs the server and dynamically manages the allocation of machine resources. Well, I would like to focus on this term a lot. Dynamically manages the allocation of machine resources. Now, this is really important because the serverless applications are really scalable. You don't have to worry about scaling your application. This cloud provider does it for you. Now, as I mentioned before, the third party cloud providers like AWS, Google Cloud, or Microsoft or Azure Cloud, they are taking the responsibility for the processes, operating systems, and servers, right? So that the developers can now focus on just building a great software. Now, all we need to do is write for the functionality, the resource consideration, like the deploying, the configuring, the let's say configuring the servers, managing the servers is not no longer our concern. So the less you are meant to manage the instance, the more serverless it is. So basically, serverless architecture is when you use cloud services to run your code without managing the servers. Is it too much to sink in? Okay, so I'll give an example. Let's say you want to buy a chocolate. Okay, so what do? You go to a shop and buy a chocolate, right? Now let me ask you something. Is it really sensible option to open up a whole new shop, manage the whole store, check for security, check for resources, and other endless things you need to do for running a shop? Doesn't make sense, right? We can easily visualize that for certain specific tasks. And let's say if we have already predefined targeted tasks, like buying a chocolate, we do not actually need to buy the whole shop. We only pay for what we need. Now it's the headache of the shopkeeper to maintain the shop. Now this is exactly what serverless is. Instead of buying or managing a whole server, we just used something called as FaaS, function as a service. We'll talk about FaaS later. So, so you're just basically saving your time and energy that can be spent on developing great products, which can scale easily. Well, in this situation, the shop is our cloud service provider, and the shopkeeper is the means to access the services of the cloud. So I hope you might have got some idea of what serverless is. If you didn't, don't worry, we'll execute the function and then I guess you'll get better idea. So I want to show you some cool stuff about the serverless technologies. Now, as you can see, these are some of the companies that are using serverless in production. Now, Netflix, it's using serverless to serve 7 billion of video hours to 50 million customers in 60 countries every quarter. That's huge, right? Now, CodePen is run by a one-man DevOps team. Now, imagine how resources are easily handled and developed by a single person, so that now you can focus your time on just building your products. Uh, I would I would suggest you to go through some of the reinvent of the Amazon events. So they really discuss a deep knowledge. They share deep. The companies basically share statistics of their companies after they're using the AWS services. Now, I would like to show you some screenshots from this reInvent of 2016. Basically, Mr. Connor, he's basically the representative of Coca-Cola. He says that for any business, the majority of time should be focused on building the products, right? How they can make their products better. Now, we are getting 39% of the business projects. Okay, 39% of the time is allocated to the ideas. But again, unplanned work, changes, and IT work, it's eating a lot of work, right? A lot of time. So they analyzed and they came to the conclusion that what the villains of the story are. Now, as I mentioned before, managing a shop, right? Now, managing a shop is not only about keep buying and selling products. You have to keep track of all products. You have to keep track if the product has expired or not. You have to keep track if any products has leakage or something, if it's damaged or something. So, managing a server comes with a lot of responsibilities, obviously. So, there's security patching, there's monitoring, there's management, there's upgrading, licensing, underutilization, overutilization, etc. So you can see there's a lot of commitment and pain gone through after you know developing a server and managing a server. So they shifted to serverless architecture, and as you can see, their business projects like the time for their they were allocating for building new products went up to 68%. Now, as you can see, the IT work and unplanned work has significantly reduced. So now they can focus on building new products. Now I want to also compare the price. It's not like that the Lambda or the serverless technology is costly. So he goes on to saying that they were using 6T2 medium instance. Medium instance is basically EC2 is basically a service provided by AWS where you can basically run your virtual virtual computer, virtual systems, and so they were hosted the servers on EC2. Now the cost was 12,864, right? And look at this, the Lambda they started and they only paid for what they used. Again, they hit only 30 millions per month. That they hit the request to the server only 30 million times. So they were only paying for those 30 million times, and each time the cost was like $1,000. So it was really cost effective. As you can see, 99% cost savings at 1 million hits per month. So it really depends on it only depends on the usage of the customer. This 62 medium instances were ideally just sitting idle when they were no use. So this is how they significantly reduce the cost. Now, as we discussed before, function as a service, right? We have many cloud service providers. We have AWS Lambda, Google Functions, Azure Functions. So now what we do is we'll make even today the later we'll make few functions that we need to deploy on AWS. We'll use AWS, and I'll tell you why. But AWS Lambda is not. It's the AWS Lambda only is not serverless. We can use a lot of other cloud functions, cloud providers as well. Um, Now here's the thing. The shopkeeper we talked about is actually very lazy. So if he sees that there are no customers lying around, what he'll do is he'll basically sleep. So this is so every time I need to make a request to the shopkeeper, I first need to wake him up. And after waking up, he'll freshen a bit and then he'll serve us. Now this whole process takes a lot of time, right? This is what we call as cold start. Now, the only downside that we have using the service architecture is the cold start. Uh, so basically, your service is basically sleeping, not actually sleeping, but every time you call, if there are no concurrent API, no concurrent calls, so the service will again copy the dependencies and go through a lot of internal uh, copying of packages and everything, and then start your application again. So now this takes a time. As you can see, this is the comparison of AWS versus GCP versus Azure. AWS takes the least amount of time to start. It's around zero point 0.2, 0.2 ms. Python takes zero point 0.5, around 5, and Go takes around 0.2 to 1. Yeah, JavaScript is faster than Go. I don't know how, but okay. GCP again takes a lot of time to compared to AWS. It's taking hell lot of time. It's around 2 ms. So again, it's not a good option. And let's not talk about Azure. Summarizing of what serverless is it's basically pay for what you use. We don't need to worry about scaling. Yeah, this is another important feature of serverless architecture. Let's say your app has like 30 concurrent users, and suddenly on the same day, your app blew out of nowhere, and it has like 30 million users per day. So you don't need to worry about scaling. The cloud providers automatically scales the application for you, so that you just focus on functionality. Again, it's language agnostic. Node.js, Python, Ruby, Java, Golang. It's supported by every language, the serverless framework, and of course, we get the security. Um, Now, let's talk about the serverless framework itself. We'll need to download a few CLIs. CLI is basically command line interfaces. Yeah. I highly recommend you to go through this documentation. I think the link is in the description of the YouTube. It has a great documentation, one of the best talks I've ever used in my life. So to install the serverless CLI, you can use Choco, curl, or just npm install -g serverless. I would recommend to use npm, but it's totally up to you. Just fire up your command prompt. I've already installed the serverless. Make sure you use --g because -g will install it globally. We require it globally. So yes, make sure you have serverless as global configuration. Other thing that we need to download is the AWS CLI. Now, this will be really helpful when we be using the technology, the all the services of AWS. It will be easy to manage and configure I'll show you once we start using those services. So I'm using Windows. You can download it from, wait, I'll give the link in the YouTube comment section. Yeah, so you can download it from here. Now, just make sure that everything is working. Just type AWS and they should pop up. So, okay, now we'll be setting up our AWS account. So make sure you have already have an AWS account. I'll be using to log in with the root account. I'll just log out again and start. Yeah. So make sure you're using your root account. This is my root account. So now this is a great service provided by AWS. So when you are in a production site, okay, so you don't want to give full access to each of your team members or each of your developers, right? So this is a great way of just telling the roles of each users. I create a new user and define their roles. So they do not interfere in other works. Like if I'm allocated to work with DynamoDB, let's say, I won't be able to access something with that is related to S3 or some services like SNS, that is just the notification services. So this is how we basically define roles. So just click on add user. I'll just create a temporary user. Make sure you have ticked both of the access types. You can just click on the next. Now, this is what I was talking about. You basically define for the user that I've made, you're basically defining the roles. I can just search DynamoDB and I can give this user full access to DynamoDB, on read-only access to DynamoDB. Or if I want to give the user access for everything, I'll just create an administrator access. Right now, we'll give the user administrator access, review, and just then go on creating user. Now, this is really important. So now open up your AWS console, the AWS CLI. Now what we'll use the power of CLI just to configure our IAM user that we've created. I'll be using my old IAM user only, so that, yeah. So basically you need to paste the access key over here, the secret access key that is here. You just need to paste it over here. Region name, the default region is AP South 1. You can choose any region, and the format. Okay, make sure that output format is YAML. We'll be using YAML throughout this course. YAML is just another formatting language, and it's basically a superset of JSON. So if you have experience with JavaScript or Node.js anything, you'll know what JSON is, JavaScript Object Notation. So it's just a superset of JSON. There is no full form of YAML. People call it yet another markup language, uh, and there are many other abbreviations, but it's just a markup language. There are no full form. So okay, once that we have configured our AWS account also, we can start coding. Now let's open up our serverless application docs. Now again, we have this docs is used pretty huge. It offers a lot of things. You can scheme a lot through the docs, and you'll get to know about this. how serverless works, but we'll just use a template that I like a lot because I'll explain why I'm using this template. So for using this template, just copy paste this thing on your terminal. I'll give the link on the YouTube. Wait. Yeah, so we'll start creating a template. Let me just name it books, and this should be it. This will create a template, and I'll explain a few things about the template. Let me open up the VS Code. Yeah, so as you can see, we have our template ready that we have downloaded from this base URL. Now, this I like this template because it already comes with the predefined dependencies. We don't need to write the dependencies again. So we'll be using serverless bundles, serverless pseudo parameters, webpack. I'll be explaining about this in a minute. But first, we'll just download these dependencies. Just write npm install. So, okay, as you can see, the serverless.yaml file. The serverless YAML file is basically the heart of our application, and this is where all the magic will happen. We'll define the functions from from the YAML file, and that will be converted to the cloud formation. Cloud formation is something that AWS recognizes as its language. It basically what serverless does is convert this serverless YAML to a cloud formation, and that CloudFormation is picked up by AWS and then sent through the API gateways or the resources that we have already defined over there. So let's just deploy our serverless application once. Let's just say it's hello, and yeah. So once we're done with the installing part, we can start deploying our server. Mhm. Mhm. So the serverless YAML file. Now, this serverless bundle, what it does is, okay, so firstly we'll define the service. So the name of the service is books, of course. Now we've used two of the plugins. Okay, let me first deploy it. So for deploying our application, we just need to write, we basically cd into the directory where we have a YAML file. So what we write is sls deploy minus v. Minus v is for the verbose. It basically gives all the details of what is happening in the behind. So yeah, so what serverless YAML file consists of is basically the first service name, plugins, the plugins that we want to use. Serverless bundle will be using two of the serverless plugins that are bundles and pseudo parameters. Now the bundle is basically a plugin that bundles our application using webpacks. Okay, so if you want to use the modern ES6 or ES7 JavaScript, we'll have to use this bundle, serverless bundle plugins. So it enables us to use the latest features, just like importing and exporting everything. So we have that. Then we'll talk about serverless pseudo parameters afterwards. It's basically it defines the AWS's parameters, so we can easily use the our AWS service. Um, Provider will be defining as the name AWS. Runtime is Node.js. We're using Node.js. Memory size of 256. Stage. Uh, this stage is basically saying that when we take the parameters from the terminal. So basically, if I write SNS deploy minus stage and I mention any of the stages, test, let's say if it's test, development, or production. So usually we'll have these three stages, and basically it deploys in the stages. Uh, Default, we'll just use the dev stage. Then we define the functions over here. Let me check on the, yeah, it's still deploying. So let me check on the handlers. So here's where we'll define the whole functions. So this is one of the function, hello function that we have defined over here. It just returns a message hello. We'll be checking out once everything is deployed. So again, we have to create a book CRUD application, right? So yeah, so let's start coding for this book application. I'll just first rename the function to create book. Just checking on the serverless. Okay, so we'll first define our create book over here, and handler is changed because it's again we have will change this name to create book. It will be a post route, of course, and slash book. So using YAML, just make sure that you are properly indenting the stuff because the indentation in YAML does matter. So make sure you are indenting it properly. So yes, we have defined a handler create book that will basically is a post route to slash book. As you can see, slash verbose gives this thing that we have created a lambda function. Uh, we have created the IAM roles. So basically, you can view the each step of what is basically going on. Okay, so let's start coding a bit. Few of the other dependencies that we'll use is what comes from the middlewares. Now, if you have already worked with Node.js or anything, you'll know that we have to use body parsers or anything to basically uh, make the format of the bodies as a JSON formats. So basically, this is it for AWS Lambda. We use something called MIDI, and we'll be using it as our middlewares. So again, MIDI is a uh, huge functionalities, a lot of functionalities, but we'll be using certain specific functions of which it's like the core, the event normalizers, the error handlers, and the JSON body parser. I'll explain about the event normalizers and the core and handler everything in a few seconds. I'll give you the link, this GitHub repo. Okay. One thing we can also mention is that we have not mentioned here the region, but we can also mention the region. It can be region specific as well. So let's say I want to make my function uh, Asia, the AP South one, which is the Mumbai region specific. So we can easily mention the region name over here. That is AP South one. But as we've already deployed our server, so we don't need to mention it. Other thing I want to mention about this YAML file is we can also make a define our custom roles. Let's say I want to make something. Let's say I want to turn off the linting. Linting is basically when it checks for the proper structure and proper syntaxes of our JavaScript code. So uh, missing semicolon or everything, it will give an error. So for this purpose, we'll just turn off our linting and wait for our. So yes, as you can see, we have our first Lambda function deployed at this ARN. So you can just check it out. Open up your web browser, just paste this thing, slash hello. Wait. Oh, okay, I've copied the wrong thing. That's why you should always use Postman. Okay, so we'll be using Postman as well. Now, as you can see, we have returned a message hello that we have coded before over here. So basically, this is as easy as it gets. We just provided the name and we have created a Lambda function just from the few lines of code. Now we can explore a lot of these things by going to the AWS console, and we'll explore them later. For now, let's just focus on building our CRUD application and setting up our DynamoDB. Now, for setting up DynamoDB, what we basically do is define few resources. Now, again, DynamoDB is a resource for our application, so we define it under resource. Now, this resource is we define it by giving it a name. So, our resource will be called books. The type of our resource is basically AWS DynamoDB table. Now, again, we need to define properties of the DynamoDB table, right? So what we'll basically do is just use the properties function, and as you can see, they've already given us the key schema and key type. Now let's talk about something called let's talk about the DynamoDB, because understanding the whole DynamoDB, uh, for understanding the language that is used by DynamoDB, it can be quite intimidating, but I'll try to explain a few terms used by DynamoDB. So first of all, what is query and scan? So okay, first of all, these are some of the terms that is used by DynamoDBs, like the sort key, partition key, query, scan, put. So query versus scan, as you can see, query is based on primary and secondary indexes. Primary and secondary indexes is basically what we define for our table, and scan is basically scans through each individual items in the database. So it's basically like the uh, approach of scanning through the whole database and returning the item. And query is based upon some of the indexes, so it's always recommended to use query over scan. Primary keys, obviously it uniquely defines each item in a table, and there are two types of primary keys: partition keys and composite primary key. Now, partition key is the main primary key that we have, which will uniquely define our book. So book ID is basically our partition key. Composite primary key is made up of partition and sort key. Now, what sort key exactly is we can make few entities like created at, deleted at. So it's easy to loop through our database. We can easily query through our database. Now, apart from these primary keys, we can also have something called secondary indexes. There are two types of secondary indexes: global secondary index and local secondary index. It's okay if for this webinar purpose, it's okay if we don't go to the in the deep structure of DynamoDB. We'll be using just the partition key and the sort. Yes, we'll be using only the partition key, but it's good to know about how DynamoDB works, right? So the global secondary index is basically consist of the other keys from the partition and composite keys. So you can basically define around 20 global secondary indexes in your database, which can be used as for querying in your database. So let's say birth date. So you can make the birth date as a global secondary index and then query through the users that are above a certain age, social security number, etc. So yeah, and the local secondary index is just basically the same partition key, but with a different sort key. Now, let's get back to the coding. Um, there are different modes of how DynamoDB works. Um, first, let me define mm, the let me define the attribute name, and as we discussed before. Now, what we'll do is we'll define our attribute for our table. So, okay, now we have books, right? So, what exactly? How we'll define the books? What is exactly our primary key? So what we do is we just define, let me check for the indentation, it's correct. Yeah, yeah. So what we do is we define the primary key of our table by saying firstly the table name, what will be our table name, books will be our table name, and what we talked about, the billing mode, is a different type of mode that is provided by a DynamoDB. So we'll use something called pay per request. Now the thing is, DynamoDB offers two modes of provisions, like on-demand mode, and other is provision mode. On-demand mode is what we are using as the pay per request, right? It's a flexible mode capable of serving 1,000 requests per second, and you use your DB as per request, right? Now, provision mode is basically you are calculating before ahead of the time that okay, I'll be using this amount of space, I'll be using this amount of read-write requests from the database, and hence I'm able to predict, and hence I want certain amount of requests only. Now, this can be economical if you can predict the usage easily, but we'll be using the on-demand mode, which is basically pay per request. Now, let's define the key schema, and but first of all, we'll define the definitions. So, definitions, as we have said, are the partition key of our book table would be ID. So, ID is what basically defines the book uniquely. So, we write attribute name ID, attribute type string. So, S defines the string. Now we can basically go on and defining the other global secondary indexes just over here, but we are not using any global secondary indexes or any sort keys, so we just need ID right now. Key schema. So our key schema will be ID, and the key type will be hash. Now you can define this attribute definition, but the Amazon will not understand what this definition is unless and until you define this thing, attribute name and hash. Now, hash is basically our partition keys. This is basically our partition keys. Okay, so now that we have set up our resources, we'll deploy it again. Let's make sure everything is correct. Linting false, yeah. So again, we'll deploy it. Self deploy minus v. And let's install few other packages. As a Node.js developer, you just work on packages, right? So we need a few more packages like UUID. So you must have used UUID. Um, You must have used UUID for defining unique IDs, and we'll be storing the hash keys over here from our UUIDs. So npm install UUID. We'll be also using AWS SDK. Now, for using any of the services of AWS, this npm package has it all. So if you want to use any of the AWS services, you have to install AWS SDK. We have already installed, I think we've already installed MIDI core, yeah, and we'll use HTTP errors. HTTP errors is just basically to make defining our errors in a proper way. Errors, yeah. Let me check on the servers. Yeah. So till now, do you guys have any doubt? You can ask on the chat. Okay, so I guess we can move on. So yeah, this is basically we'll start coding for our create book. So we'll first import our libraries that we already downloaded right now. So first, let me import UUID. So there's a version of UUID known as V4. So we'll deconstruct V4. We'll only use V4 from the UUID library. So and UUID package. Sorry. Um, we'll also import AWS. Importing V4 as UUID is basically defining giving name to V4 as UUID. Then we'll import AWS from our AWS SDK. Then we'll use the MIDI our MIDI packages that we are already installed. So basically, we'll be using MIDI core, JSON body parser, event normalizer, error handlers, create events. Now let me check on the server and let's start with defining our book. So, okay, our book will be consisting of ID, first of all ID, that will be defining from UUID, a title, let's say author, image URL for the storing images, and description of the book. So this is what our book will consist of. Okay, so I think, yeah, so we have created our book. We have created our, I think, AWS. So let's explore some things about uh, the AWS console, what it gives. So when you look through a console, so open up CloudFormation. CloudFormation is basically where you'll be able to see your application hosted. So book devs, this is what we have defined before, right? This was the name of our service. So as you can see, these are the whole lot of services that we defined just from a few bunch lines of code. So here is our DynamoDB table. Here is our Lambda function. Here is our log group, and here is our IAM. So as you can see how powerful the serverless can be, right? Just from writing a few lines of code, you have created this many services. Now, we'll be looking at the Lambda function. Uh, Also, you can the basically the this is what the cloud formation has done. We basically converted our serverless YAML into a function, into a service. We can test our service as well. Um, this is basically our IAM rules. We'll be talking about IAM rules later. And this is basically our DynamoDB table that we've defined. As you can see right now, there's no items, no matrices, no nothing, no indexes defined. So yes, so to explore everything, you have this cloud formation and you can explore it anytime, anywhere. So this is again a REST API gateway. So we'll be creating the REST APIs right now. Okay, so let's get back to coding. hmm So we have defined a book, and let's try to use the DynamoDB service. Now we'll define DynamoDB from AWS, of course, or AWS that we have the package that we've installed. Let's say DynamoDB is equal to new AWS dot DynamoDB document client and a function. Now, what this exactly is, I'll show you in a minute. Let me open up the slide. hmm Yeah. So basically, this is what these are the whole bunch of functions that AWS that document client provides us from the cloud formation. Everything we have basically get routes, put routes, querying, scanning, updating everything from this document client. So I encourage you to go through this once. I've given the link in the description or in the chat box. So yes, we'll be using some of the functions of document client like get, put, query, scan, etc. So now let's get to coding. We have defined a DynamoDB as the document client. Now what we'll do is wrap up around this async function. We'll uh, deconstruct title, author, image URL, and description from our events.body. Events.body, right? And we basically this will be getting from the body from our request, and we can easily deconstruct this using the this event.body. Now what we'll do is try to put our object into our DynamoDB. We'll wrap it around a try catch block. Try catch. If there's an error, we just console log the error and throw new HTTPS errors. And for trying, so what exactly we'll do is DynamoDB dot put and then params. Now this is something to be taken care of. Um, this is the syntax that DynamoDB uses. It requires a table name and an item. Because we are putting this book into the table, so we're basically putting this item to this table name that will define. Our table name is books, and table name will define and dot promise. Now this is a cool feature of AWS SDK. You can wrap around you can promisify any AWS functions just by putting dot promise. Okay, so now we have put up the books, book item book that we got from the body, requests body, and we have catch any if any catch the errors. Now what we have to do is use the middlewares. Now this event.body, this is not exactly in the JSON format. So what we need to do is wrap this create book function. Okay, we'll basically create a MIDI function, and then we'll loop around the other middlewares like HTTP, let's say error handlers dot use HTTP normalizer. Now HTTP normalizer is basically something that saves us from the room of errors. So when you give our when you file a request from for and you give the params to a request to a body, it basically checks the params and the body structures, and it's used for saving us from the errors. Next thing we're going to use is HTTP body parser. So basically this event.body is not exactly in a JSON format, so we need to parse it to a JSON format, and then we'll be good to go. We'll deploy it again, deploy a function again, SLS deploy -v. This is how we have, we have to deploy each and every time. Mm, just wait for a few seconds. You can ask if any questions you have. You'll get used to using this basically format of putting out the every functions of DynamoDB. There are, as I as we saw in the document.client uh, docs, that we had many of the query, put, scan, and we'll be using those functions as well. So till then, let's create our other function. Okay, why does deploying takes so much of time? So when we do actually SLS deploy, right? SLS deploy basically bundles your application whole thing. So what the serverless framework does is it automates the process of creating all the necessary services on the cloud. So once you run SLS deploy, the config file which we had, the serverless YAML, is transformed into a cloud formation template. Uh, as I said, CloudFormation is a special language AWS uses to spin the services by running commands on the file. So once it is spinned up to the CloudFormation template, it is sent to AWS to create services specified by you. So we have defined services like DynamoDB, right? Now the CloudFormation will basically send requests to the DynamoDB service to create few services. Now, apart from this, making of services, making the API gateway routes, all lambdas, everything else is specified. It also packages up your code that it sends to AWS S3. If you have worked with AWS S3, S3 is basically somewhere, as you can see here. Uh, this whole file is stored in AWS S3. It's basically a storage provided by Amazon. It's basically converting this whole code into a zip file into S3. It stores this file into S3, and then the bucket of all the previous version is deleted, and the new version that we have deployed is updated. We upload it, and then the serverless grabs the latest version. This is the whole process it goes behind. Ideally, what actually we can do is not deploy the whole application again. We can just deploy functions. I'll show you how we can deploy functions only. But once you are changing serverless YAML file, we'll have to change the the architecture again. So we need to deploy the whole application again. So I hope I cleared your answer or cleared your query. Hmm. So okay, so let's create other functions. Let's say getBooks.js. Other will be getBook.js. Basically querying querying through like specifying the IDs, and will take out the book from there by defining the partition key. Delete book, create update and update book. Okay, so we'll just copy paste this thing into a V, and we'll move to that get book thing. Get books, this is get books. So this basically returns every book. Mm, Serverless, yeah. So it shows that we have defined our create book and it's ready to fire up. So first, let's make our get books route as well, and then we'll test out both the routes. So okay, get books. So what we need to change here is we don't need this. We Yeah. Uh, Actually, we should return the book, right? So what I'll do is the object that we've created, I'll return the book. Yes, so I'll return the book instead of message. I'll just return the book. Get books. So what else do we need to? Okay, we'll have the try catch block. Yeah. So we want each and every book of the our table, our database, right? So what we'll do is define a result. On this is equal to await Dynamodb dot scan. Of course, it's not recommended to use scan but again we need to retrieve the whole database. So we are using scan. It's okay to use scan here. We'll be using query and getting a single book, but for retrieving the whole database, we can easily use scan. So again, we have defined that we scan the table called books, and then we store it in a result. Again, let's define books as result dot items. Now, we are doing this because this result won't only it return a lot of things, but we just require the items, right? So we'll just extract the items from our result and send it to our response that are books. Cool. So we have extracted result.items from books, and we are scanning the database, and this will basically return the books table into the result. Then we're extracting the books. Okay, looks clean. Create book. Dynamodb. So since we have not made any changes in our serverless YAML file, we can actually deploy our function only. Let's say function get books. Okay, so again we need to define get books, right? We don't have any get book function. So let's define the get books function. Get books. This is the name of the function which will act as infrastructure handler. We can just copy paste from here. Get books. Then we'll define events HTTP. This is basically saying that it is going to be HTTP request. Method is obviously get, not get attribute. Get, and the path will define as slash books following the REST convention. Hmm, let's define our other functions as well. Okay, so I'm getting error, and there's book. There might be some indentation error. Hmm. So let me check the. Okay, we have. Okay, yes. So it showed that getBooks isn't defined. We have not defined the getBooks yet. So first, let me do one thing is just create the whole functionalities, the function that we need to use in our CRUD application. So let's define another function called getBook. Mhm. This is basically getBook handler event HTTP. Now this is way of defining the specific parameters. So if you have used with any of the backend services, you might have known this is the REST convention of using or defining the parameters. So we'll be just defining the parameters like the curly braces, and inside the curly braces we give the ID or any parameters that we have. So this was the get book. Now we'll add delete and update book. Okay, so now we have delete, update book. So the only change that we have in the method is in the method. Again, we will specify the IDs in parameters. So the method here is delete and here is patch, again following the RESTful convention. Okay, so now I think we can I'll just copy paste the same code in each for right now so that we don't get any errors. And then we'll deploy it again. SLS deploy -v. So let's work on getBook now. So basically extracting a single book using ID, right? So what we'll use here is instead of scan, we'll use something called get. Okay. So again, table name as books. Now, one extra thing that we have now here is our predefined parameters in our event, right? So let's just first make let variable book because it can be variable, it can be changed again. We'll deconstruct our ID from parameters. So let's say event dot path parameters is where we'll define the ID constructor ID from. And now what we'll do is just make a search query. Just check on. Okay, so we've got an error on handler found update book. Okay, update book JS. Okay, so it was basically in the wrong directory. So I moved into the handlers again, and now we can deploy it again. So again, this is the get book for using ID. So we have deconstructed ID from event.path parameters. We'll again use the syntax of Dynamodb dot get because again we need only one book. Because it will be uniquely defined by this ID. Again, so now we'll define the key. So what exactly we need to query through. So again, so we have said that we'll query this book using the ID. Okay, so this get is basically search loop through our DynamoDB database and search for this query and return the result from over here. the book that we had defined before. Wait. Mhm. Yes, so the book that we had defined before will be result.item. Just make sure that you're using result.item here, not items, result.item, and we can catch if there's any errors and return book. Simple as that. Let me search where are, okay. So this was basically our get book functionality. Now what we can do is copy paste this code and do a delete function. Dynamodb again will just deconstruct the ID again as we saw here. We'll be using /book/ID. So we'll get ID from this parameters and then we'll delete the specific book of that ID. So for delete book, what we need to do is function called dynamodb.delete. Table name, books again, key, ID. Basically, we need to delete this function. Now, we can also parse a function through this so that even if there's some errors, we get to know what the error was. So just to, make sure that this delete operation is working fine, we'll just again use a internal function that returns we just use the internal function that returns basically the error if there's any errors, console.log errors, promisify, and we do not require this in any delete function. Catch error, console.log error, throw a new error, this thing, create book, HTTP event handlers. Okay, great. Create book. Okay, so we need to change our function name from everywhere, I think. Create book. This is get books. This is get book. Delete book. Okay, all right. Get book, delete book, get books. Hmm. Let's check on our server. Using template. So usually it doesn't take this much of time, of course, but I don't think what's happening. Maybe some issues with my internet connectivity, but it does not take this much long. Okay, so we have we'll finish the update book as well. Hmm. Let me just check the code. Cool. So let's write about the update functionalities. So if you have any doubts, please let me know now. Right, so we'll move to the update book part. Again, we'll use something called a function called update, and we'll use this expression. So I'll just copy paste this code that I have here and explain a bit about it. Hmm, Try. Okay, we do not have any environment specified. Actually, We can specify our environment also if you want to, but for now let's leave it as it is. Books, table name books, author. So, okay, so this is the syntax that DynamoDB follows. Table name, of course, and the key, which which item has to be changed, which item has to be updated. Set author equals to A, title equals to T. And then we'll deconstruct the author and title from, of course, the event.body or path parameters, whichever we like. But we'll deconstruct author and title from event body. Const author and title equals to event.body. So we'll be getting our new updated author and title from our event.body, and we'll be using to set up to change the author and title of the ID of the book of ID specified over here. So update expression author equals to A, title equals to A. A is equal to the author that we deconstructed from our body. T is equal to title. This is the basically the syntax of DynamoDB that we need to follow. Expression attribute values. Update expression is the main key things. Now again, let's try to change our this thing function. DynamoDB.update will pass params and function. So this time we have defined params separately in create books and other things. We didn't specify any separate params. So we have defined params separately. We pass params and function to the update functions that we have, and this will basically return if there's any error. Succeeded if it's if it has run successfully. We are not required to print anything. We just return updated message updated. Same goes for delete. We just return a message called deleted. Get book returns book. Update book returns updated. So let's check on our thing. Deleted. Get book. Get books. So let's talk about the IAM roles that we have discussed before. So ideally what we can do is define the specific roles to the specific persons. Like this person should only have the read access to the DynamoDB, right? So what we'll do is if we go to our cloud formation, hmm, where's the IAM manager? Yeah, so this is the IAM manager thing. It's loading. So as you can see over here, this is basically the policies that is attached to the IAM user that we're using right now, that is using this function called books. Now the user has CloudWatch logs only. So when you try to query to DynamoDB, it will return you an error because of course you are not allowed to access the servers. Now you can easily attach policies over here from here. Let's get DynamoDB. You can easily give full access to this user, attach policies. This is again something we not recommend to give the users, and to follow infrastructure, something called infrastructure as code. We define the IAM roles something like this. I'll show you in our code. So for our environment, for our provider settings, we just define a set of IAM roles, right? So what we can do is copy paste. Yeah. So effect allow, action, put item, scanning, get item, delete item, update item. So you're basically allowing each user for putting this particular user to put the item, scan the item, get the item, delete the item, update item. So ideally, you can follow this infrastructure, updating the items as per role. It's not compulsory to give full access to anyone. So I would recommend going to this rather than attaching the full rather than attaching the full access to the user. Now this is something you need to take care of. Resource, and to get this ARN, not this, we have to search for DynamoDB's ARN. So ARN is basically Amazon resources name. It basically gives a unique name, and that is how our Amazon recognizes the services that we are going to use. hmm Okay, so we have books. We'll open up books. So you need to copy paste this ARN over here. Mhm. Yeah, so you need to copy paste the ARN that we are using is over here. This is basically the our region slash books, and that should be it, I guess. You can directly attach the policies, of course, instead of defining whole this bunch of rules. But of course, this is also an option. So let's check on our servers. Uh, we need to deploy our servers once again because we have defined a whole bunch of lot of other functionalities, and we have basically coded the CRUD operations. So I guess this will be our final deploy, I hope. I'll just go through the code once. Let me know if you have any doubts. Update books, document plan, event context. Yeah, so I guess we'll wait for a few minutes. Let me know if you have any questions about serverless to ask. So cons. So basically cons, I said the main con is about the cold start that we have, right? So again, the the function requires a lot of time to heat up, and it's if you're running an EC2 instance, right? So your instance will constantly run. You don't have to break anything. But again, there's this cold start in case of serverless applications, serverless architectures. So we cannot break this cold start. We have to go through this cold start every time. So 0. 0.2 seconds, 0. 0.5 seconds, 0. 0.7 second delay might seem nothing, but again, for a high-end technological, a high-end, high data speed requiring application, it's a quite a lot of uh, latency. So we do not recommend using those. But again, there are a few ways of using keeping this function alive every time by firing the routes, let's say each hour or every 2 hour, every 3 hours, so that it's always heated up. Wait, what are we making? We are making basically a CRUD applications of books. So basically, uh, there's a book that has ID, title, author, image, URL, description, and we are basing we're wrapping around the the CRUD applications using AWS Lambda. We're using the functionality of AWS Lambda and DynamoDB as well for our database, and we're just waiting for our Serverless application to upload its file. It's getting uploaded. Till then, we can fire up our Postman. So I hope you might have used Postman. Postman is basically API testing tool. If you're a backend developer, you might have used Postman. This is basically our body. This is where our request is sent from. If we give a params from here, we can define variables like here. I've put the value of our ARN that we had over here. So basically, we don't have to copy paste this ARN again. We can just use AWS dev as the variable, as you can see here, AWS dev variable. It's getting loaded. Let's explore a few things about the cloud formation, the resources that's provided by the cloud formation. So as you can see, now we have defined a few functions like the get books for Lambda functions, delete book Lambda functions, update book Lambda function, create book Lambda function. So this is basically the log group. I guess we can check the log group of each function. So let's say if there's an error in our code, we can just basically go through our logs and just check. Okay, I think we are good to go now. So, okay, add book. Okay, this is basically our title, auth, CodeChef-VIT, image URL. So we'll just send a request to our, as you can see, this is taking 1 second. Ideally, it's not a good time, but of course, uh, this is what is basically con of using serverless technology. because for a simple application, our server can return this in basically 200 or 300 ms, 300 microseconds. So as you can see, we have this ID. We can just copy paste this ID over here. Again, 954 ms. This is not this is a little bit slow, but again, if you compare pros and cons, uh, obviously the pros exceeds the cons. Now let me make a bunch of other books just so that we have idea about all the books. I'll just make a few same similar books. Right. So this is basically get all books, good book, good book. This is basically the bunch of books that we created right now. So let's just say I want to delete a particular book. What was the name of, yeah. Let's say I want to delete this particular book. Mhm. We don't need body actually, just the params. As you can see, it's deleted. We'll search again and copy paste this author name and send again. We'll search for that author, and yes, as you can see, there are no result. We have successfully deleted that book, particular book. We can also update the book. Let's say we want to update. Okay, so every book has similar names. So let's just update this book with the ID of E6. So pass ID, author Shivam, and updated title. As you can see, updated. I'll just copy paste this again. So as you can see, we have successfully updated name. Oh, and this was actually really fast. Again, I said the starting bit, which has the cold start that we talked about, that was only affecting. Once it is heated up, you can see you're getting the fast request. So basically, you in a serverless architecture, what we need to focus is if we have getting concurrent requests and it's not getting idle for a large amount of time, we can use serverless easily. So yes, this was it. We created the CRUD applications. Let me know if you have any doubts. Otherwise, we can end it now. Okay, guys. Thank you for staying. Thank you for tuning. We have other workshops for Golang and data science lined up. So make sure you subscribe our channel and make sure that you follow the same. Uh, I hope you got to learn something new, and make sure you follow the other session that we're going to hold, which is for Golang and data science. Golang is basically we'll be creating the same book cloud application. So yeah, thank you guys.